Right, good morning everyone. It is me again. So today I'm going to be talking, it's quite a general talk about various bits of research that we've done and how we kind of have learned a bit more about the forest canopy as we've gone on with that. So I want to start by talking about a little bit about rarity and how we conceptualize rarity. And there are three essential ways you can measure rarity. You can look at things that have low population sizes, we would call them quite rare. Things that are geographically really small distribution, those could be considered rare, and something that occurs in a specialized habitat, we could also consider that rare. And obviously, if you can have species that fit two of these or three of these, and so you have different combinations of how things express their rarity. But this is also from a human perspective, and so it's reliant on there actually being observations there. And if we don't look in the right place, or don't look at the right time, we're going to have a skewed view of what rarity is. So I'm going to use an example from the birds. This, for those of you who don't know, is a pin-tailed white-eye. In summer, they look like this. In winter, they look like this. And if you look at observation records through the year, you see that despite the effort for most people through the year being more or less even in the yellow there, the blue line shows that in winter, no one can identify them. And so part of the rarity is definitely what the people who are out there observing things find. And with flies, we have a similar example. This is a chrysogaster. If you go out in October and November, you can collect hundreds of them if you know the right habitat to go to. If you go at another time of year, you won't find adults at all. They're still there. They're just larvae, probably in the mud, and no one goes and looks in the mud, and so they're not detectable. And so we need to also think about rarity and detectability, and those two things are not the same. Okay, so what if we don't go to the right place? Or what if there's something happening and we're not looking in the right place? And this is clearly something that we see in the canopy. So a lot of people go to forests and they walk around the forest. There are wonderful trails through forests that you can walk on. But you stay, as a human, at about a 2-meter level. And everything that's happening above you, you don't notice what's going on. And so we've noticed that since 2000, with increased collecting effort, we've got a lot more records of these species and genera that were considered quite rare. And I'm going to talk today about three of them: Malota, Myolepta, and Afroxanthandrus. Malota is probably the most common of these historically, but we still see more than half of the known specimens collected since the year 2000. Myolepta, it's about 2/3, and Afroxanthandrus is even more impressive, with 3/4 of them collected in the last 25 years. But the idea that the canopy might be something important comes from quite a long time ago. And Brian Stuckenberg was quoted in Chris Thompson's paper in 1974, suggesting that Myolepta might be something that's occurring in the canopy. So how since 1974 to 2000 nothing happened, and since 2000 we've had a change? Well, the big shift has been in how we go out and sample and what we're doing with these specimens. So we're collecting a lot more larvae, rearing them through, and we've managed to get that a lot of Malota specimens and new species from that. We've also had people looking in the canopy doing specifically pollination studies, where instead of walking through a forest and exploring the ground level, they go to 1 or 2 sites, but go up and sit in the canopy and let the insects come to them. And that's produced new records. And then we've had various places where we've placed traps in the canopy, and instead of trapping at ground level, by looking higher up, we start turning new species up that way. So let's look at these in a bit more detail. So Malota, we recently revised this genus, and we got 4 new species from the Afrotropics. Where at least one of those species was a new species reared from larvae, where we went and we found larvae in a rot hole in a tree. Now, a lot of the trees, as they get bigger, they branch, and you have rot holes quite high up, and that's the larval habitat. But larval habitats also attract females so that they can lay eggs, and often attract males because they know the females are going to go there, so it's a good place to look for mates. And so once you find rot holes that by chance happen low enough down, you can rear the larvae and get this idea of what's happening up above you. They are quite widespread, but we tend to always find them with large trees nearby. So even when we've collected them on roadsides, at flowering plants, you can always see trees nearby that are potential spots for them to come from. But the vast majority of what we have had in the last 25 years are from forests, and we know there's some link to this, that it's happening with the trees, and obviously when they've got a forest, there's a higher density of trees, and that's where these animals are hanging out. But importantly, we also found them, they were also found in a pollination study in the canopies in the Tsitsikamma forest. Okay, so that's another good indicator that we have that they're occurring in the canopy. Myolepta, we have one undescribed species. It's still sitting in my office. It's being worked on. We will get there. We know that they're coming in the Congo out of baited canopy traps. It's something that was, up until 2000, known from 4 specimens across Africa. Those 4 specimens are 3 different species. We're now turning up multiples of them in the canopy in the Congo, the Republic of Congo, and turning up other specimens from West Africa and fresh specimens from South Africa by focusing on the canopy. Okay, all of them are from forests or very, very close to the forest. So sometimes we collect them on the margin of the forest, but it's clear that they're related to the forest directly. And then just to touch on Afrexanthandrus, we had 2 new species of Afrexanthandrus described last year. Also from the canopy, from baited canopy traps in the Congo, turning up comparatively huge numbers from these traps, whereas we pick them up once or twice. Normally we find them in the understory after bad weather. So if we have a couple of days of really cold weather, these animals get desperate for food, they can't find enough food in the canopy anymore, they come down for nectar and you pick them up in flowers after the bad weather. So the day after a cold front, if you have nice warm weather, it's very good to get them there. These ones, always from forests as well. We've never found them outside of the forests. Okay, and again, one of them turned up in the pollination study in the forest canopy. So this collecting in the canopy, obviously there's something happening there. We need to look at it in more detail. But I also just want to touch on what it does for our knowledge of the distribution of the species. So up until the year 2000, Afrexanthandrus was known from roughly that distribution over there, really restricted, thought to be just a deep Congo or rainforest specialist. And now we have a massive distribution across basically all of Africa. And so it's not the fact that it's a rainforest, it's the fact that it's a forest that makes it interesting for these species. I do want to touch on one other thing, and that we shouldn't get too hung up on the forest specialists. So this is Afrosurface. It was described as a forest specialist by Midgley et al. But does it need to be a whole forest, or does it just need to be a tree? Well, we know from the center of Makanda, we have one specimen from there, and if we zoom in, it's just some large trees in the back of a garden, okay, at the Albany Museum. So clearly, sometimes just a couple of trees are enough, but it's still something that's happening in the canopy of those trees and not something that you're going to find down on the ground very often, unless there's a good floral resource or some reason for those animals to come out of the canopy. So it's clear from from what we have here and all of the descriptions of the new species that we found that the canopy still needs a lot more attention in South Africa and Africa in general. Most other continents have a permanent setup of a sampling of some kind of canopy crane where people can sample fauna of the canopy and do dedicated research on it. We don't have anything like that in Africa. The best you can do is sometimes find an aerial boardwalk in a forest that gives you a bit of access, but it's not a dedicated sampling point. You can't use a crane to get around and look at other areas. So we are kind of on the back foot in that way, but it's still something we should think about and how we can get out there and get better things. Just a general increase in collecting effort will help, but you should kind of think about what's going to draw animals out of a forest. If you're interested in looking at the canopy species, go out at times when we know we'll have things that are coming down from the canopy. So if you see bad weather coming, it's not necessarily a bad thing. You can use that to your advantage by saying, let's go and focus our collecting in the couple of days after that when we should have good weather. And then when you're out there, try to get up into the canopies. So often in South Africa, the forests are on slopes, and you can use that slope to your advantage to try and look into the higher up canopy sections and try to get interesting specimens from there. And it's not just a simple value for one thing. You can have taxonomic value, you can have biogeographic value, and we think that there is something that if we put some more focus and effort in, we're going to get a lot more interesting biology out of these things as well. We just need to spend some time out there doing it. So that is what I wanted to say. Thank you all for listening. If you'd like to find out more about some of these species that were described, there are posters outside. You can go and have a look at that there, but more information about the things that are using the canopy. But until then, happy to take questions.
Okay, thank you very much, John. We have time for a few questions.
Thank you, John, for the speech. It's a bit of a controversial method, but has canopy fogging been considered in South Africa, or would it be a good way to get syrphids?
So I know some people have done canopy fogging. Charles Haddad, sitting at the back there, has done fogging for spiders. My gut feeling is it's not a great way to collect syrphids. I think that if you've got something that's relatively sedentary and you fog for it, then they get overwhelmed by the pesticide and they drop down. But things that can fly or are very willing to fly, let's rather say, they don't tend to turn up in the fogging samples. So when the hoverflies get sense that there's something bad smell, or for whatever reason they see the insecticide coming, they tend to move out the way, and we don't see huge numbers of them dropping out. I don't know, Charles, yeah? Charles is agreeing, yeah.
Good. Thank you very much, John. So we'll wait for another 3 minutes to continue.